All right, so far we've talked about kinetic energy and gravitational potential energy, and now we're going to talk about spring potential energy. So, spring potential energy is how much energy there is stored in a spring because of how much it is compressed or stretched. So, depending on how much you have stretched your spring or squished your spring, you will notice that as you stretch it, the force you need to stretch it a little bit more is bigger and bigger the more you stretch it. This is called Hooke's Law. And some springs follow this straight line of Hooke's Law exactly perfectly. And we're going to remember that the change in energy um, is going to be equal to work, and that is equal to the area underneath a force versus distance graph. Now, in the uh, energy lecture video number 2, I go over all of the derivation of this, but in summary, that area then underneath the force versus distance graph for a spring is going to be equal to the work done by the spring and therefore your change in energy or the energy stored in your spring. So if I find the area of this, I'm going to end up with 1/2 times my spring constant times the distance that I've stretched it squared. So the spring constant in this equation is going to be how hard it is to stretch or squish the spring. For example, the spring in a pen is really easy to squish compared to the springs like for the shocks on a train or the shocks on your car or even a playground toy spring. The x in this equation is the distance the spring is compressed or stretched. So here in the middle, I have uh, a picture of a spring attached to a block and it's just sitting there at rest. This is how long the spring wants to be without anything pulling or pushing on it. If I compress the spring, that distance that I've compressed it is going to be my x. It does not matter how big this spring is. It only matters how much the difference is between equilibrium, or where it wants to be when nothing's pushing on it, and where it is after I push on it. The same thing is true for the stretch spring. I'm measuring from equilibrium to how much I've stretched it, and that's going to be the x in this equation. If you have any questions, let me know.